Here are the solutions for the multiple choice questions on the Unit B review for your probability exam. So let's start with problems 6 through 8. We're looking at a two-way table which has 125 truck owners who are asked what brand of truck they owned and whether or not the truck has four-wheel drive. The results are summarized in that table, and we're going to randomly select one of these truck owners. What is the probability the person owns a Dodge or has a four-wheel drive? So if I look at it very basically, Dodge or four-wheel drive, that means I got to count the trucks that are either Dodges or four-wheel drives, and then divide that by the total number of trucks. So here are the trucks that are Dodges. Here are the trucks that are four-wheel drive. Now, if you're looking at them individually, it's fine. So I'm going to do that 28, 32, 20, and 10 over 125, right? Now, if you were looking at totals, you have to be very careful with that 20 because it's counted in both totals. It's counted in the total number of Dodges and the total number of four-wheel drives. So don't double count those. And when I add these all up, I get 90 over 125, which matches our answer. Now, there is another way to do it using the formula. So we have the formula probability of A or B equals probability of A plus probability of B minus probability of A and B. So probability of a Dodge is 30 out of 125. Probability of four-wheel drive is 80 out of 125. So that's if I add the totals. Then I have to subtract out that double count, which is the 20 over 125, and I get the same answer. Now we want to know what is the probability the person owns a Chevy given that the truck has a four-wheel drive. Now, you can just look at this simply by looking at the table without using any fancy formulas. So we need to know, we're only looking at four-wheel drive trucks, and we want to know what's the probability to have a Chevy. So here's the Chevy that's four-wheel drive, and there's all the four-wheel drives, right? So Chevy and four-wheel drive is that 32, and then I have to divide by all the four-wheel drive trucks, and I get 32 over 80. I can also do this with a formula. Probability of Chevy given four-wheel drive is the same as probability of Chevy and four-wheel drive over probability of four-wheel drive. So Chevy and four-wheel drive is 32 out of 125. Probability of four-wheel drive is 80 out of 125. And then since you're dividing two fractions, use the reciprocal and multiply, and you get 32 over 80, which is the exact same answer. So you can approach these problems a couple different ways. I think the first approach is pretty straightforward. When you start going to formulas automatically, be careful with that on probability. You have to make sure you understand the situation before you just jump to a formula. Okay, which of the following is true about the events owner has a Chevy and owner's truck has four-wheel drive? So what I'm going to look at is the probability of a Chevy given they have four-wheel drive. And we just did that math. That was 32 over 80, or 2/5. Then I look at probability of just Chevys in general, and I get 40 over 125, which is 8/25. So those are not the same numbers. So since the probabilities are not the same, then they are not independent. And so also they're not mutually exclusive because you can have a truck that is both a Chevy and a four-wheel drive. So the probability of Chevy and four-wheel drive is not zero. So they are neither mutually exclusive or independent. Number 9, a spinner has 3 equally sized regions, blue, red, and green. Johnny spins the spinner 3 times and gets 3 blues in a row. If he spins the spinner 297 more times, how many more blues is he most likely to get? So we know the probability is 1/3 because there are 3 equally sized regions. And the spinner doesn't remember that 3 blues in a row were spun. So you have to ignore what happened until that point. And then we expect 1/3 of the next spins to be blues. So we expect 99 more blues. Okay, now we're looking at Wilt. Like Wilt Chamberlain is a fine basketball player, but his free throw shooting could use some work. For the past 3 seasons, he has made only 56% of his free throws. His coach sends him to a summer clinic to work on a shot, and when he returns, his coach has him step to the free throw line and take 50 shots. He makes 34 shots. Is this result convincing evidence that Wilt's free throw shooting has improved? We want to perform a simulation to estimate the probability that a 56% free throw shooter would make 34 or more in a sample of 50 shots. Which of the following is a correct way to perform the simulation? So just in general, if I was using a number line, and you should be able to do this with a random number line, hint, hint, wink, wink, nudge, nudge, all right? Then I need to use digits. So I need 100 total outcomes with 56 for success. I only need 2 digits to model 100 outcomes because if I have the digit 00, that would be the number 100. Now, here we're using a random number generator, so it's not as big an issue. So here they're saying generate integers from 1 to 34, making a free throw, and 35 to 50, missing a free throw. Generate 50 random integers. Well, the problem is I need 56 out of 100 outcomes to be success. And with this model, it's giving me more like 68. So it has the wrong number of outcomes. It's giving me 68% success instead of 56% success. Let's look at the next one. Let integers 1 through 56 represent making a free throw, and 57 to 100 represent missing a free throw. Generate 50 random integers from 1 to 100. Since they are generating from, where's my pointer? Since they are generating 1 to 100, we don't have to do that weird 00 thing. But if you were using a number line, wink, wink, nudge, nudge, I would probably, you could say 1 to 56 represents making a free throw, and then 57 to 99 and 00 represent missing a free throw. That would work fine. So this one actually does work. B will work because we're using a random number generator instead of random number table, so I don't have to worry about that weird 3-digit number and that being a 1-digit number. I'm going to skip C for right now because it looks like B is already correct. Let's go ahead and look at D. Let integers 1 through 34 represent a free throw. So this is the same problem as choice A. It has the wrong number of total outcomes. This does 68%. 34 out of 50 outcomes represent success, but he only shoots 56%. So this is too high a free throw shooting rate for him. And I think what it is they're saying, oh, we want to know if 34. Don't let that 34 confuse you at this part, all right? We're going to get to that later. All right. Then finally, choice E, let integers from 1 to 56 represent making a free throw, and 57 to 100 represent missing a free throw. Here, the difference is they say no repeats allowed. We're not really sampling and not putting back. Attempts that you can repeat over for infinity, we can have repeats. So don't ignore repeats because we're not sampling. We're just simulating, okay? So the correct answer is B. Now we're going to look at the result of 100 simulated shots. So what we're going to do is 100 simulations of 50 shots. So keep those two numbers straight in your mind. 100 simulations, there are 100 dots here. And 50, each dot represents how many successes out of 50 free throws. So count number of shots at 34 or higher. So that would be these. So that's really the number of simulations. 3 simulations had 34 or higher shots made. And then we calculate the probability. 3 out of 100. You're probably really tempted to do 3 out of 50, but it's 3 out of 100 because there are 100 dots here for 100 simulations. Then, so don't mix that up. So we get 0.03. So it's one of these choices, A or B. What is our assumption here? Our simulation was based on 56%. So if Wilt were still only a 56% shooter, that's the assumption we use. The probability he would make at least 34 of his shots is only about 3% or 0.03. This is if Wilt is now shooting better. No, that's not the assumption we did. We were doing 56%, not better than 56%. So that is why the correct answer is A. So here's number 12. The table shows the probability of AP scores for students in a particular class. We select a student at random. If the student scored a 3 or higher, what is the probability the student scored a 5? So first of all, we're going to mix in some of our probabilities. I'm definitely going to need probability of 3 or higher, so we'll get there. So first of all, I have a missing point, right? Missing point. Where is my point? So I need to figure out this missing point. I know that all my probabilities must add up to 1. So I'm just going to go 1 minus the rest of these probabilities, and I get the value 0.3. So I'm going to put that in there. I do need to know what is the probability a student scored 3 or higher. That's not the answer. It's super tempting to think it's the answer, but it's not the answer. So let's go ahead and calculate that, and I get 0.7. Okay. Now, what are they asking for? They're asking for the probability of a 5 given 3 or higher. So you have to look at the probability they scored a 3 or higher and got a 5, which, by the way, is just 0.15. And then the probability they got a 3 or higher, which we just calculated. So we get 0.214. So lots of places to fall down on this problem. Pay attention to what it's asking for. It asked for the probability of getting a 5 given you were in this box already. So again, a place where people often trip up on probability problems. Number 13, in a class where there are 18 girls and 14 boys, the teacher selects 2 students at random to attend a party with the principal. What is the probability that 2 students are the same sex? So that means we're looking at the probability of 2 girls or 2 boys. All right. And so I'm going to find the probability of girl first, 18 out of 32, because there are 32 total kids. Then I have 1 girl. She's not going back in the pile. And so there are 17 girls left out of 31. And when I multiply those 2 out, I get 306 over 992. The probability of 2 boys, I start with 14 out of 32, and then I multiply by 13 out of 31. I get 182 out of 992. So, but I'm looking for the probability of either of these situations occurring. So I would say probability of girl plus probability of boy minus probability I get both girl and boy. But those are mutually exclusive, so that's going to turn into a 0. So I'm going to put in my fractions. You can see my 0 right there, right? And then when I add them all up, I get 488 over 992, which is 0.492. So there's the solution to number 13. The security system in the house has 2 units that set off an alarm when motion is detected. Neither one is entirely reliable, but one or both always go off. That's important to know. When there is a motion anywhere in the house. Suppose that for motion in a certain location, the probability that detector A goes off and detector B does not is 0.25. Probability that detector A does not go off at all is 0.35. What is the probability detector B goes off? So I'm going to do a Venn diagram here, and I'm going to put A and B. I notice that one always goes off, so that outside area is 0. We know you're either going to be an A or B or both, right? And then we know that the probability that detector A goes off and B does not is 0.25, so I'm going to put a 0.25 there. Probability that detector A does not go off, well, the only spot left for A not going off is right here, 0.35, because it couldn't be in the 0 section, because we know we have 0 probability of being there. Then I know that all of these have to add up to 1, right? So I'm going to subtract to find that A and B. And you're probably going, wait a second, it's not asking for A or and B. But trust me, this will help. So we're going to find that last probability, which is 0.4. They want the probability that B goes off, so it's just both of these probabilities combined, or 0.75. Question 15. Suppose that a student is randomly selected from a large high school. The probability that the student is a senior is 0.22. The probability the student has a driver's license is 0.30. So let me do that. Probability of senior is 0.22. Driver's license is 0.3. And then they say the probability is a senior or has a driver's license is 0.36, which is right there. Okay. So what I'm going to do is, and they want to know what is the probability of senior and driver's license. So this is from your formula chart, which you're allowed to use on the test. senior or driver's license equals, so probability of A or B equals probability of A plus probability of B minus the probability of both. So I just replace that with senior and driver's license, and I'm going to put in all the numbers I know. You'll notice this is the only one I have to solve for, combine those two, and then I'll move these around. And I get 0.16 is the probability that they're a senior and they have a driver's license. And that's it.